Hello everyone and welcome back. Today we're going to be looking at notes on the three main types of rocks, which are igneous rocks, sedimentary rocks, and metamorphic rocks. We'll start by taking a look at igneous rocks, which if you can tell from the pictures here, is the result of magma and lava. Igneous rocks form when any type of rock has been melted into a liquid or molten rock and then cooled back into a solid rock again. And there's a few key terms to know with this process. First, magma is liquid rock that is under the surface of the earth. Lava is liquid rock that is on the surface of the earth. And crystallization is the process of cooling to form solid crystal rock. Igneous rocks can be classified based on a couple of different features, the size of their crystals and also their coloration. We'll start by looking at how crystal size tells us about igneous rocks. And to start with, we have intrusive igneous rocks. So intrusive rocks cool very slowly underground. And since they cool slowly, it results in having very large crystals that are visible with the naked eye. Two examples of intrusive rocks are to the right. There's granite, and you can see there's light and dark colored crystals, but mostly light here. And the granite, and then there's diorite, which has a more even mix of light crystals and dark crystals, but the crystals are big enough to be seen with the naked eye. The other type of crystal size comes from extrusive igneous rocks. And extrusive rocks cool very quickly on the surface of the earth. And this means that they cool so quickly that their crystals don't get large enough to be seen with the naked eye. And here we have a lighter colored rhyolite. And again, the crystals in this rhyolite are too small to be seen with the naked eye. It just looks like a smooth rock. And then on the extreme end of cooling quickly, we have obsidian. And obsidian is actually a glass. It cools so quickly that there's no crystalline structure that forms. We have a true glass. So again, intrusive rocks cool slowly underground, resulting in large crystals, and extrusive rocks cool quickly above ground, so they have very small crystals that can't be seen with the naked eye. The second part of classifying igneous rocks has to do with their coloration, and there's some terms you'll need to know with that too. The first is felsic. Felsic rocks are very light colored. They have very few dark crystals, like this granite that is just to the right. This granite right here is a felsic rock. The next type of coloration is known as intermediate. And intermediate rocks are about half light colored crystals and half dark colored crystals. If it's an intrusive rock, it might look like this diorite, where you can see both of the crystals in the light and dark color of this diorite. If it's an extrusive rock that doesn't have clear crystals, it might just be kind of a light gray colored rock. The last coloration is mafic. And mafic rocks are very dark. You can see here is some basalt. And the basalt is almost entirely dark. You'll also find sometimes an even darker coloration of rock that's called ultramafic, but for our class, felsic, intermediate, and mafic are good enough. And then finally for igneous rocks, we can look at both of those classifications put together. So we have a table that shows both intrusive and extrusive. So the rocks in this left-hand column are all intrusive rocks, meaning they've cooled slowly and have large crystals. And the rocks in the right side column are all extrusive, meaning they cooled very quickly and have smaller crystals. And then the rows are the coloration ranging from felsic to intermediate and mafic. So first rock here is granite. Granite is a felsic rock because it's very light colored, and it is intrusive because it has large crystals. Rhyolite is a extrusive felsic rock. It has very small crystals and it's lighter colored. For intermediate coloration, the intrusive rock is diorite. It has large crystal sizes and an even mix of light and dark colors. And the extrusive rock for that is andesite. It's tough to tell on this image, but andesite is a bit darker than rhyolite. And finally, for mafic rocks, the mafic rocks are intrusive is gabbro, and it has larger crystals, but it's still a very dark colored rock. And our extrusive rock is basalt, and basalt has very small crystals, but it is very dark coloration. The next type of rock that we'll be looking at is sedimentary rock. And sedimentary rocks form through several processes of weathering, erosion, deposition, and cementing. Going forward, we'll take a look at these processes in more detail. First, let's look at the definition of weathering. Weathering is the process of breaking down rock into smaller pieces. So this is taking a big rock and then breaking it into many smaller sized rocks. There is two main types of weathering, chemical weathering and mechanical weathering. Let's take a look at chemical weathering first. Chemical weathering is caused by chemical reactions. These could be a mineral called feldspar reacting to form clay. So if you ever see clay, that formed from a chemical reaction weathering rock. Water can dissolve limestone. This picture to the left here is an example of what can happen when water dissolves limestone. This is how caves form. And then sometimes that rock is redeposited into these stalactites and stalagmites that you see hovering from the ceiling and growing up from the ground. And then finally, iron that can be in rock can rust when it reacts with oxygen, and that forms a reddish coloration to a lot of rocks. So again, chemical weathering is due to chemical reactions. It could be forming clay, water dissolving limestone, or iron rusting when it reacts with oxygen. The second type of weathering is mechanical weathering. Again, mechanical weathering is due to physical forces actually breaking rock down. So this isn't chemical reactions, these are physical forces. And this could be, as an example, abrasion. An abrasion would be rubbing against something to wear it down, much like sandpaper can do to wood. You can use sandpaper to abrasion against wood, and it'll smooth that wood out. We could have frost or root wedging. And frost wedging is when water gets into a crack of a rock, and when it freezes, that ice expands and it can break the rocks apart. Root wedging is very similar, but it's due to plants having their roots grow into rocks, and as the roots grow larger over time, it breaks the rock apart. Salt weathering, again, can happen when salty water gets into rocks. As the water evaporates, the salt reforms its crystals, and those grow, breaking rock apart. And finally, heat expansion, because things get bigger as they get warmer. So when rocks get warm, they can expand, and that can cause cracking and breaking. So again, physical forces cause mechanical weathering. The next process that I want to talk about is erosion. And erosion is the process of moving broken down rock material. So it's moving that weathered material. This can happen due to gravity, like a rock slide. Gravity causes rivers to flow, and rivers can carry sediments. We have rock slides, river sediments. Wind can carry smaller pieces of rock like sand and silt. To our left, we actually have a picture of a massive sandstorm. And then one of the most powerful forces that can move rocks is glaciers. Glaciers move so slowly that they don't look like they're moving, but they're very powerful and they can carry huge boulders very, very large distances. So again, erosion is the process of moving broken down rock material. When that eroded material stops moving, we say that it has been deposited. So that is our next process, deposition. And deposition is the laying down of eroded materials to make new formations. A common example that most people have seen are sand dunes. Sand dunes are deposited sand. We also have river deltas. Over here is a river delta. A lot of river sediments get deposited at that delta point. At the end of glaciers, we have terminal moraines. So here's our glacier, and you can see a huge strip of deposited material at the end of that glacier that's called a terminal moraine. The ocean floor, it constantly has sediment being deposited, and then also dead creatures that have shells deposit on the ocean floor, and those shells can build up to make rocks. And then at the end of rivers, we can also have alluvial fans. So this is when a river ends up over land, not necessarily over water, but this is a nice alluvial fan here. So again, deposition is the laying down of eroded materials that make new formations. And after enough time, those broken down sediments might be cemented to form a new rock, and that's what we would call sedimentary rock. So if those sediments have been cemented into a single rock structure, it is now a sedimentary rock. Next, we'll take a look at how sedimentary rocks are actually classified, because there's two main features that we look at when we classify sedimentary rocks. The first is that sedimentary rocks are defined by the size of the sediments or the size of the grains that make up the rock, and then also how well sorted the grains are. If you look at the pictures to the left, this first rock here is shale. It has very, very small grains, smaller than you can hardly see with your eye. Next is sandstone. These are sand-sized grains, and you can actually see the individual grains that make up the rock, but they're still very small. And the rock to the right is a good example of two things. This is what's known as a conglomerate. So it has very large chunks, pebble-sized chunks making up the rock. And since there's different sized grains making up, we would say that it's poorly sorted. The left two rocks are well sorted, but we can look at that in more detail on the next slide. So again, looking at grain size and sorting here. Sorting is pretty straightforward. Rocks that have only a single grain size within that rock, like this siltstone and this sandstone, are very well sorted. They have only the same size of sediment or grain within that rock. Things that are poorly sorted have multiple grain sizes like this conglomerate rock here. And then looking in more detail at grain sizes, we have this diagram on the right. The smallest grain size that we have is called clay. It's something that's smaller than 4/1000ths of a millimeter. It's very, very small. You cannot see it with your naked eye. Going larger, we go to silt. Then we have fine sand, medium grained sand, and coarse sand. And coarse sand is the first thing that is the size of a millimeter, and millimeters are very, very small. So most of our grains within sedimentary rock is very small. Next up, we have something called a granule, and this is something that is 2 to 4 millimeters large. And then pebbles. And pebbles can get very large, up to 64 millimeters or almost 3 inches. So pebbles can get very large, but once you get larger grains, it is harder for them to form into a rock. So these coarse sand grains are the largest size grain you would see cemented into a well sorted rock. Anything larger than that is going to end up being more of a conglomerate where it's cemented with finer grains but contains some larger materials like granules and pebbles as well. And our last type of rock that we're going to be looking at is metamorphic rocks. And what metamorphic rocks are is really held within their name, because meta means to change and morph means shape. So metamorphic rocks are rocks that have changed their shape. And to do this, and I'm going to switch color to differentiate here, metamorphic rocks change their structure or their shape due to large amounts of heat pressure, or both. So the rock undergoes huge amounts of heat or huge amounts of pressure, but the rock does not entirely melt during this process. And this is really important because if the rock melted entirely, when it re-solidified, it would be igneous rock, not metamorphic rock. So this is just getting hot enough to try to change the crystals within a rock without melting the rock. Any type of rock can undergo metamorphosis, but metamorphic rocks are defined by their degree of metamorphosis. So they can change very little or they can change quite a bit, and it's how much they change, which is how they are defined. Now, the rock that was changed, so the rock that they changed from is called the parent rock. And the parent rock can be sedimentary, it can be igneous, it can already be a metamorphic rock that changes again. So any type of rock can metamorphose, and we call the first rock the parent rock, and then the new metamorphic rock, or what it has changed into, is called the daughter rock. So again, we have a parent rock and a daughter rock. On the next slide, we're going to look at a sequence of metamorphic rocks. So this slide shows us how rocks can change based on their degree of metamorphosis. And we start with a parent rock. The parent rock is shale, and I'm highlighting it up here in the top right corner. And we're going to look at how the daughter rocks change as they experience greater degrees of metamorphosis or greater amounts of change. So the least changed metamorphic rock is called slate. So shale can metamorphose into slate. And you'll notice that shale and slate look very similar. Their colorations are very similar. The only difference, and you'd really need to hold the rocks to see this, is that slate has a little bit larger crystal structure. So some of the sediments in that shale have kind of merged together to form larger crystals, but overall they look very, very similar. As the degree of metamorphosis increases, so it is exposed to more heat or more pressure or both again, we get a rock that's called schist. And schist again has these flaky, smooth portions that you see within slate and shale, but the crystals have continued to grow and they've become almost a little bit shiny. If you see a nice piece schist rock, the top portion looks very shiny and almost metallic. And then again, it can undergo even greater amounts of heat and pressure, and we get what's called gneiss. And gneiss is named for the banding that you see, these dark and light bands throughout the rock. It's called gneissic banding. And what's happened with this metamorphic rock is it has partially melted. So it has not completely melted, so it's not igneous rock, but the partial melting has allowed these layers to separate by density. Remember, anytime we have liquids and there's gravity involved, they'll separate by their densities. And we can see that starting to happen where the dark and light rocks, which have different densities, are beginning to separate out into distinctive bands. They didn't melt all the way, so they were able to cool and form these distinctive bandings. So again, the important information here is that metamorphic rocks are defined by their degree of change, with less changed being the lower amounts of heat and pressure, and the greater change having more heat and pressure. So I know this was a lot, but in this video we took a look at igneous rocks and how they're classified, sedimentary rocks and how they are classified, and also metamorphic rocks and how those are classified. Feel free to watch this video multiple times if you need to, because again, it is a lot of information, but that's it for me. See you guys next time.